Hello students, we already started the ionic equilibria. Okay, now today's point is hydrolysis of salt. Okay, now see here, hydrolysis of salts. Now see here, before see the hydrolysis, I will just repeat the point. The autoionization of water, the pure water ionizes as H plus and OH minus ion. Is it? H2O ionizes to give H plus and OH minus ion. Right? In the pure water, some of the molecules dissociates or ionizes to give H plus and OH minus ions. Is it? Actually, see here, that is, this is the equilibrium exists in the case of pure water. But H plus ion does not remain as H plus ion in the water. They combine with the H2O molecule, forming H3O, hydronium ion. So while writing this equation, we used to write H2O, this is the original ion, to ionize H plus and OH minus. One more molecule for this hydrogen to combine, forming H3O plus, and this as usual OH minus ion. Okay, instead of writing this, while writing this, we have to use one more molecule to show this hydronium ion simply. Remember. Okay, now see what is the meaning of hydrolysis now. Is it? See here, in neutral water, this H plus ion always equals to OH minus ion. It is clear? H ions means equal to hydronium ion equals to OH minus ion. When a particular salt like NaCl, KCl, CuSO4, whatever salt may be, KCN or any salt, when dissolved in water, okay, any type of a salt when dissolved in water, if this equality does not disturbs, remains same, then the resultant solution will be neutral. What I said, when a particular salt dissolves in water, then there is no interaction. If there is no interaction of the ions of the salt with either H plus or OH minus, then the equality does not disturbs. That means H plus equals to OH minus, or H3O hydronium ion equals to OH minus ion. That means the resultant solution will be neutral. And on the other hand, if ions of the salt reacts with one of the H plus or OH minus ions, or one of the cation or anion of the salt reacts with the water, then the solution, resulting solution will be acidic or basic or neutral also. This is the hydrolysis. Hydrolysis means the reaction of ions of the salt with water, that means H plus or OH minus, to produce acidic, basic or neutral solution, that is called as the hydrolysis. Now hydrolysis of the salt is defined as the reaction in which cation or anion or both ions of the salt reacts with ions of water to produce acidity or alkalinity or neutrality. Okay, this is the hydrolysis, remember. Now this you remember, instead of writing where we used to write this H3O, to write H3O hydronium ion, we need one more water molecule. That is the main thing. Okay, now different types of salts. Here I will just write Types of salt. Types of salt. Salt of strong acid and strong base. Salt derived from strong acid and strong base. Okay, then salt derived from strong acid and weak base. Number 3, salt derived from weak acid and strong base. Then we are going to see detail all these things. I am just explaining on the paper in short. Salt derived from weak acid and weak base. These are the 4 types of the salts. Okay. The salt derived from strong acid and strong base, the examples are, that is NaCl, KCl, Na2SO4, etc. and even KNO3. These are the salt derived from the strong acid and strong base. Now what is the meaning of salt derived from the strong acid and strong base? As you know, the strong acid is HCl and the strong base is NaOH. These two salts reacts to form NaCl plus H reacts with OH to give H2O. NaCl, right? HCl reacts with NaOH to produce NaCl. So this NaCl example of the salt of strong acid HCl and strong base NaOH. Likewise KCl, Na2SO4. KCl is the salt derived from the KOH, strong base and weak strong acid HCl. Now Na2SO4. This is a salt of strong acid and strong base because this is derived from strong base NaOH and strong acid H2SO4, right? So these are the examples of the salt derived from the strong acid and strong base. Now likewise the salt derived from the strong acid and weak base, that is the example you can take as NH4Cl and even CuSO4. Now NH4Cl, it is a salt of strong acid, and how NH4OH here is a weak base and HCl is a strong acid. In case of CuOH taken twice, okay, that is CuOH taken twice is the weak base and H2SO4 is the strong acid. Now salt derived from the weak acid and strong base, the example is CH3, weak base and strong acid CH3COONE, and that is KCN. Example is KCN. Okay. Now this is a salt derived from the weak acid and strong base. How? Because CH3COOH, acetic acid, as the weak acid and NaOH is the strong base. KCN is again the salt of weak acid and strong base. Weak acid is, that is HCN, hydrogen cyanide, is the weak acid and strong base KOH is the strong base. Now salt derived from the weak acid and weak base, that is NH4OH is the example. That means NH4OH is the example. You can take the example, that is CH3COO NH4 ammonium acetate is the example. Even you can take the example of NH4CN. Okay. Now this is the salt derived from the weak acid and weak base. Which is the weak acid? This is CH3COOH, acetic acid is the weak base, and NH4OH is the CH3COOH is the weak acid and NH4OH is the weak base. Okay. And NH4CN is the, again, in a second example of a salt derived from the weak acid and weak base. Here which is the weak acid? This HCN is the weak acid, weak base, NH4OH is the weak base, right? Like this, by taking the example of reaction we have just derived. So these are the few examples of salt of weak acid, salt of that is salt derived from the strong acid and strong base, salt derived from the strong acid and weak base, salt derived from the that is weak acid and strong base, salt derived from the weak acid and weak base. All this is explained on the page number 53 of textbook. Okay, now now we have just saw concept of hydrolysis and types of salts. Okay, that is, what is the hydrolysis? What is hydrolysis? When a salt dissolved in water, then the cation or anion of the salt or both react with ions of water to produce a resultant solution as acidic or basic or neutral. This is called as hydrolysis of salt. Now let us say the hydrolysis of first type of salt, salt of strong acid and strong base. We are taking the example of salt of strong acid and strong base, that is NaCl. NaCl in the water ionizes as Na plus and Cl minus. Okay, so this is the term in the textbook, that is 3.7.3 textbook. Okay, now Na plus and Cl minus ions are present in the water, that is water solution of NaCl. Then NaCl, both of the ion reacts with H2O to give HCl and NaOH, strong acid and strong base. Now again both are strong acids, strong acid and strong base. They dissociate in water again, Na plus and Cl minus. Now see here, what here is shown. Both being strong, they give Cl minus and Na plus ions, and formation of H and OH. On separation, H combines with H2O to form hydronium ion and OH minus. That means here H3O responsible for the acidic nature and OH minus responsible for the basic nature are in equal amount, you can say. That's why the resultant solution is neutral. Okay, here the ions of Na plus and Cl minus have no tendency to react with water. The ions of this salt Na plus and Cl minus does not have the tendency to react with water. This is because the possible product is NaOH and NaOH and HCl of the reaction are strong electrolytes and dissociates completely in aqueous solution to give Na plus and Cl minus. Now here the reactant and product are the same. This implies that neither cation nor anion of the salt reacts with water and there is no hydrolysis. There is equal amount of these two ions. That's why it is concluded that the salt of strong acid and strong base does not undergo hydrolysis. Okay, now the next type of the salt is salt of strong acid and strong base. Salt of weak base, strong acid and weak base. Here the example is CuSO4, as we have discussed in the type of salt. How is the salt derived from the strong acid and weak base? Copper sulfate. Now copper sulfate in the aqueous solution dissociates to give Cu2 plus and SO4 2 minus. Okay, now among these two salts, SO4 2 minus ions of the salt have no tendency to react with water because the possible product is sulfuric acid H2SO4, which is again strong electrolyte. And the reaction of Cu2 ions, now only Cu2 ions reacts with water. That means here CuOH reacts with water actually to give CuOH minus 2 minus and H plus ion. Okay, we need 2 for the balanced reaction, right? But here H plus ion in the aqueous solution does not remain as H plus. They reacts with 2H2O to give here, that is twice of 2H2O 2H3O plus hydronium ions, right? It gives hydronium ions. Okay, that's why we have to take here 4H2O. Okay, so instead of writing, now we can write directly here, that is twice of H3O plus hydronium ions, and these are responsible for acidic nature. Okay, now here, due to the presence of excess of H3O ions, the resulting solution of copper sulfate becomes acidic in nature and turns blue litmus red. But here, because of the formation of CuOH taken twice, a sparingly soluble salt, is it? This is the sparingly soluble electrolyte, weak base. That's why the aqueous solution of this becomes turbid. And to form the clear solution, we have to add H2SO4. H2SO4 means it contains H plus ion, it contains H3O plus ions, and the equilibrium shifts to the left side, and the turbidity of CuOH gets dissolved in the solution and formation of the clear solution takes place. So to get clear solution of copper sulfate, the addition of H2SO4 would be required. Okay, now the next is the hydrolysis of salt of weak acid and strong base. The example of salt derived from the weak acid and the strong base is CH3CONA. Here weak acid is CH3COH, acetic acid, and the strong base is NaOH. Now in the aqueous solution, this dissociates to give CH3CO minus and Na plus. Alright. Now here the solution of CH3CONA contains Na plus and H3O plus, CH3CO minus and OH minus, right? So in this case, actually Na plus have no tendency to react with water, you can say, or OH minus ions of the water, since the possible product of the reaction is NaOH, a strong electrolyte. But CH3CO minus, they have a tendency to react with water. That means they reacts with H2O. They reacts with H2O, is it, forming CH3COOH, acetic acid, a weak electrolyte, weak acid, and OH minus remains in the solution. Is it? See here, CH3CO ions reacts with water or reacts with hydronium ion or reacts with H plus ion, forming undissociable CH3COH acetic acid molecules, is it? And the resultant solution contains OH minus ions. Okay, that's why the solution will becomes basic in nature, and the solution of CH3CONA is therefore basic in nature. Okay, that means it turns red litmus blue. Okay, now the last is hydrolysis of salt of weak acid and weak base. That means the salt which is derived from weak acid and weak base. Example, last time we have just seen the example of CH3CONH4. Is it? This is a salt of, as an example, a salt of weak acid and weak base. Here weak acid is acetic acid CH3COH and the weak base is NH4OH. Is it? Now here we are considering a BA, salt BA, which is derived from weak acid and weak base. Instead of perfect example, Now this salt dissociate in water to form Ba plus and OH minus ion, cation and anion. This Ba plus and Ea minus reacts with water to form BOH and HA, a base BOH and HA. Now here this is being a salt of weak acid and weak base, it is very difficult to say whether BOH is weak or HA is weak, whether out of this which is stronger, and the resultant solution either it is acidic or basic. Okay, the solution may turns out acidic, basic or neutral depending upon the relative strength of the weak base and weak acid formed here in the hydrolysis process. Okay, now see here that this can be decided depending upon the acid dissociation constant value and base dissociation constant value, K and Kb. K is the dissociation constant of acid, Kb is the dissociation constant, that is dissociation constant of base dissociation constant. Now here if K is greater than Kb out of these two, then the resultant solution is acidic. If K is less than Kb, then the resultant solution will be basic. And if K is equals to Kb, the resultant solution will be neutral. Okay, so this is all about the concept of hydrolysis. You just go through the textbook on page number 54. Page number 54. Okay, and if any doubt, if you have, you just call me or chat with me my personal number on WhatsApp, or directly you can call. Okay.